All right, continuing with chapter 8, we're going to be looking at the Pythagorean theorem, which I assume everybody's familiar with. We've already been using it. So you know how it works, but we're going to get into a few details and talk about using it in a little more advanced arena, maybe? So anyways, Pythagorean theorem and its converse. We know the Pythagorean theorem says that in a right triangle, the sum of the squares of the lengths of the legs, so those are our two shorter sides, legs, is equal to the square of the length of the hypotenuse. Hypotenuse, importantly, is across from the right angle, so wherever the right angle is, that's the hypotenuse. So this is going to be an important name. I know we're all familiar with it, but when we get a little bit further and get to trigonometry, we're going to be talking about things relative to opposite sides, adjacent sides, and hypotenuse, so it's important. There's a list of some Pythagorean triples. I think I mentioned in class the ones that I bother to memorize are multiples of 3, 4, 5. So if we have that ratio, or ratio of 5, 12, 13, those are the two smallest two smallest first numbers, I guess, or smallest hypotenuse. And then there's a couple more ratios, 8, 15, 17, 7, 24, 25. There are other ones bigger than that. But remember that anything that has that ratio, anything that's proportional to these triples is also itself going to be a triple, because that would just be a similar triangle scaled up by whatever factor. So if we have 5, 12, 13 and we double that, or we triple it, or we quadruple it, those are still going to be right triangles. Okay, so an example problem for Pythagorean theorem. It says the length of the sail along the mast is 82.5 feet. The mast goes this way. If you don't know that, it doesn't matter, because we just need our two leg lengths. If I reverse them and put the 82.5 here and the 29.25 here, I would still get the exact same hypotenuse value. So I don't want to do that by hand, so we have 82.5 squared plus 29.25 squared, and I could turn those into a fraction. I could make it like 165 halves, and I could square that, and then I could do a huge number like 80 and 36 and 117 over 4. I could square that, and then I could add them together. That sounds terrible. So I'm going to go ahead and, for a change, use a calculator and do that on there. So just a simple calculator, nothing fancy. So we have 29.25 squared plus 82.5 squared, and then we're going to square root, I did that wrong, plus 82.5, I don't use this calculator very often, equals, then we're going to square root that sum and get our sail length, or hypotenuse, is about 87.53. It says round to 3 decimal places. I don't really care. 87.532, sure. 87.532 feet. So importantly, we check back at our two legs, and they are shorter than that, which is good, because the hypotenuse has to be the longest side. If you mess it up, then that won't be longer than those. We also just have our normal rule about what makes a triangle, which is that this one has to be the biggest, but can't be bigger than the sum of those. So we have a pretty limited range in which it can fall, and we can use some kind of a sanity check to make sure it makes sense. Okay, you're standing beside the Colorado River, 500 feet from the Hoover Dam. Okay, so we have 500 feet from the dam. I'm going to draw that left to right. And then the distance to the top of the dam goes up, is 985 feet. We want to find distance to the top of the dam. Oh, so the distance to the top of the dam, that's a weird way of wording that, would be from where we're standing to the top. So that's our hypotenuse, is 985. And then this would be x, the unknown thing. So here we had the two legs. We square and add them. We have a leg and a hypotenuse here. So we're going to need to rearrange a little, and we'll do 985 squared minus 500 squared, and then we'll square root that nonsense. So back to our calculator, let's clear that. We got 985 squared minus 500 squared equals, square root that, we get, what does it say, 3 decimals again, 848.661, because we have a 7 there, we'll round up. 848.661 is approximately. So first time we're using imprecise answers, we're going to put approximately that instead of exactly that. So we've used equal, we've used congruent, we've used similar to, and then if you do an equal sign where it's 2 of those tilde symbols stacked up, it's like an approximation. So it's not an exactly equal to, because we have a rounded answer. And keep in mind, we could solve these perfectly, right? We could get exact values with radicals and simplify it. It would just be really ugly, and it would be hard to estimate what that number actually meant. So I did go through this one earlier and do this by hand, and it ended up with something in the hundreds of thousands over 16 or over 4, and none of it simplified. And it was just like, what does that even mean? There's no way I could tell that it meant 87 when it was done. Okay, so that's our Pythagorean theorem and how we use it. The converse is basically going from the sides to determine that we have a right triangle. So if the sum of the squares, I need to make a picture. If the sum of the squares of the lengths of the legs, sides of a triangle? Okay. So we don't know their legs, so we don't know it's a right triangle. So let's call them the shortest 2 sides of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle. So that in and of itself is all right, but it actually goes a little beyond just the converse of Pythagorean theorem, which is the Pythagorean inequality theorem. So this theorem can tell us if a triangle is a acute, obtuse, or right triangle based on the 3 lengths. So we have this relationship a squared plus b squared, and then we have c squared. So we know that if they're exactly equal, that is a right triangle, and it has to be perfectly equal. But if a squared plus b squared, so imagine my right triangle like this, a squared plus b squared is equal to c squared. But now I make one of my legs, or I make my leg, how do I want to say? So I'm keeping c squared the same, but now a squared plus b squared is going to be bigger than c squared, which means that these need to be a little bit longer than what they are. So if I did that, then my hypotenuse is also going to need to get a bit longer. So what that does is it opens up this angle, and now it's greater than 90 degrees. So if a squared plus b squared is greater than c squared, then we have an obtuse triangle. And the other way around, if we make a squared plus b squared shorter, so we have a squared and b squared. Wait, I did it backwards. Oh, of course I did. So I shouldn't be talking about a and b. That's not even how I think about it. Why am I explaining it that way? So we have a and b, right? They are what they are. Now, what I want to think about is, what if my hypotenuse gets, so this is perfect, now what if it gets a little longer? So if c squared is a little bit bigger, then now to finish my triangle, this angle opens up and becomes obtuse. So this is if c squared is greater than a squared plus b squared, then we get a obtuse triangle. So I tried to go in the order you write it, which is a squared plus b squared, but what I really care about is this hypotenuse and what it is. So c squared is bigger than a squared plus b squared, we get obtuse. So of course that's the same as saying a squared plus b squared is less than c squared, but to me it makes more sense to think about that one single side and whether it perfectly fits these two to make a right angle or whether it's too long or too short. So our other option is c squared is too small. It's smaller than a squared plus b squared, and that would give us an acute triangle. So that would basically mean, again, I have my a and my b, but instead of being exactly long enough, it's too short. My hypotenuse doesn't reach as far as it needs to, so then I have to swing this side around over to here, and I end up with an acute angle instead of a right angle. So it's all about the hypotenuse, whether it's exactly the right size, too big, or too small, kind of like a Goldilocks situation. I haven't read through these blanks. It says if the square of the length of the longest side, so that's our c squared, is greater, less than. Oh, neat. They even actually write it with c squared first. Well, I could go to that then. Then less than the sum of the squares of the lengths of the other two sides in the triangle is an acute triangle. If c squared... Oh no, this is both options. Wait. And the triangle is an acute triangle. If c squared is less than a squared, the triangle is acute. Is that just repeating the same thing? I guess so. Okay. If the square of the length of the longest side is greater than the sum of the squares of the lengths of the other two sides, the triangle is an obtuse triangle. So if c squared is greater than a squared plus b squared, then the triangle is obtuse. Great. That's the easy way of saying it, and that's what I was writing here. I actually do prefer writing it this way around, with the focus on the hypotenuse rather than the focus on the a and b, but really it doesn't matter, because you can write the inequality backwards and it doesn't matter. So c squared is bigger than a squared plus b squared, c squared is less than a squared plus b squared. And all throughout this, we're still following our normal rule of triangles, which is that no side can be bigger than the sum of the other two. Okay, so classify each triangle as acute, right, or obtuse. Well, 9, 12, 15 is a ratio of 3, 4, 5, because that's 3 times 3, 3 times 4, 3 times 5. So this one is a right triangle for sure. It follows our simplest Pythagorean triple. This one, we're going to square the three sides, and we can't rely on the picture to know what's longest and shortest. So we don't want to make any judgments about this being the long side. We want to just go ahead and square everything. So we have 15 squared, we have 36 squared, and we have 4 square root of 95 squared. So 15 squared is 225, I know that one. 36 squared, I have no idea, but I don't need a calculator for that. We can just do 36 times 36. So that 6 times 6 is 36, carry a 3, get 18, that's 21. 0, 3 times 6 is 18, carry a 1, that's 10. So 1296. And then 4 square root of 95 squared. Well, the square root of 95 squared is going to become a normal 95. But the 4 squared is going to become 16. So we're going to do 16 times 95. 5 times 16 is 80. 9 times 16 is 90 and 72. 90 and 54. What am I saying? 90 and 54, which is 144. Right, 4, carry 5, 9, 14. Yes, okay. So that is 1520, I believe. So that is our longest side, and we want to know, is the sum of these exactly that, since those are the two shorter ones? So that would be 1, nope, it's not exactly, so let's see if it's bigger or smaller. So that's a 1, carry a 1, we get a 2, and carry another 1, we get a 5, 15, 21. So the sum of those is too big, barely, just barely. So c squared is a little bit too small, meaning this is acute. C squared needs to be one more for it to be a right triangle. Okay, this one we've got 7 squared is 49, 8 squared is 64, and square root of 113 squared is 113. These are our two shorter sides. They make 113, so that is a right triangle. So that's how Pythagorean inequality works, is just finding the squares of the three sides, adding the two shortest ones, and seeing if it's the right size for that hypotenuse or not. Okay, decide whether this is acute, obtuse, or right. So basically, we need to find the lengths of each of those sides. So we could also find slopes, but since we're doing Pythagorean, we want to do distances here. But we could very easily do the slopes of these three and see if there's a right angle in there. Anyways, my distance from A to B, I go 8 and I go 4, so 8 squared plus 4 squared. And then from B to C, I go 11 squared plus 2 squared. So I'm just counting the distance, right? From 6 to -5, that's 11 distance. From 0 to -2 is 2 distance. And then from C back to A, that's 3 distance from -5 over to -2. And then -2 to 4 is 6 distance. So I really don't need to simplify these. I just can do this is square root of 68. This is square root of 121 plus 4. And this is square root of 36 and 9, 45. So then I would be comparing 68 plus 45 versus 125. So 68 and 45 gives me 113. And my c squared is greater. So c squared is greater than 113, meaning that this is an obtuse triangle. Drawing that one would also certainly help. Since we have the actual coordinates, we could visualize it really easily if we drew it. Okay, so that pretty well covers our notes, and then there's just practice to do. Let's go ahead and fill in this reminder. So if C, I'm going to focus everything on c squared because I really do like that way better. So if c squared is equal to a squared plus b squared, the triangle is right. If c squared is greater than a squared plus b squared, the triangle is obtuse. And if c squared is less than a squared plus b squared, then the triangle is acute. So we're going to go through each of these. We're going to determine if they could form a triangle, and then determine if it's acute, right, or obtuse. So we have 2 checks. So first check here is this could be a triangle because 3 plus 7 is more than 9, right? 9 is not too big to fit in that triangle. So then we would look at the squares. So this is 9, 49, 81. 81 is much bigger than 58, so that's going to be obtuse. And then 20, 21, 29, that is a triangle. 4, 11, 16 is not a triangle because 4 plus 11 is 15. 16 is too long for it to even be a triangle. So that's not a triangle. So for these, classify them if they are triangles. Remember that it has to be greater, right? So 8 and 15 is exactly 23. So this is not a triangle. And if it were, so say this were 24 instead of 23, it would be very, very obtuse anyways. Because with 8 and then 15, so 8, 15, and then if we had just barely bigger, like 24, that's still going to be, these are almost in a straight flat line, so it's going to be a huge angle, way bigger than a right triangle. So yeah, go ahead and work on the practice for this, but it should pretty much all be familiar. The only really kind of different thing is that addition of the inequalities, but hopefully pretty easy lesson for you.